Welcome viewers. In this video we'll see the solved problem based on the AC through capacitance only. The circuit containing only the capacitance, for that we can see the solved problem. We'll see the first problem. A 135 microfarad capacitor has 150 voltage and 50 hertz supply. 135 microfarad capacitor is connected across the 150 volt 50 hertz supply. We need to calculate capacitive reactance, equation of the current, instantaneous power, average power, RMS current, maximum power delivered to the capacitor. These are the parameters we need to calculate. So the given data, this Vrms is given as 150 voltage. The capacitor given as 135 microfarad, that is 135 into 10 to the power minus 6 farad. Micro is 10 to the power minus 6. The frequency given as 50 Hz. So these are all the data available. First we will calculate the capacitive reactance. The formula is Xc equal to 1 divided by omega c. This omega is nothing but 2 pi f, angular velocity. So Xc equal to 1 by omega c, that is equal to 1 divided by 2 pi fc. So 2 into pi into f into c. F is available 50 Hz. C also available 135 into 10 to the power minus 6. So by simplifying this we got 23.58 ohm. The reactance also is a resistant, like a resistant. The unit is ohm. 23.58 ohm. Now we'll go to the equation of the current. I equal to Im sin omega t plus pi by 2. So this is the general equation. I equal to Im. This plus pi by 2 is nothing but due to capacitance. The capacitor, the current is leading the voltage. So it is plus pi by 2. Plus pi by 2 indicates the current leads the voltage by pi by 2. So that it is given as omega t plus pi by 2. Now how will you find Im? Im equal to omega c Vm. We can find the Im by using this formula. So Im equal to omega is nothing but 2 pi f into c. This Vm is nothing but root 2 Vrms. Only the Vrms is given. So Vm is nothing but root 2 into Vrms. So Im equal to omega c Vm. Omega is 2 pi f into c. Vm is root 2 Vrms. Now substitute all the value. 2 into pi into f is 50 and the c value is 135 into 10 to the power minus 6 into root 2. The Vrms is 150. So by simplifying this we got 8.99 amperes. So that can be substituted in the equation. I equal to Im sin omega t, so that I equal to 8.99. So this Im is 8.99 sin 314. 314 is, that is omega t equal to 2 pi ft. So if you substitute all the value, we will get 314 t. Right? The omega t for 50 Hz supply, it is 314 t plus pi by 2. So we got the equation for the current. This pi by 2 indicates the current through the capacitor leads the voltage by pi by 2, that is 90 degree. Now we'll go to the instantaneous power. Instantaneous power is Vm Im sin omega t into cos omega t. So formula is available. So Vm is root 2 Vrms. Similarly Im is, as Im is already given, sin omega t cos omega t. So that root 2 into Vrms is 150. Current is 8.99. That's now we calculated Im. Into sin 314t and cos 314t. Right? This omega is nothing but 314. Omega t is 314t. So by simplifying this we got 1907.04. This sin 314t and cos 314t, that can be written as sin 2 theta divided by 2 based on the formula. Sin 2 theta equal to 2 sin theta cos theta. Bring the 2 denominator. So sin 2 theta divided by 2 is nothing but sin theta into cos theta. So this sin theta cos theta is written as sin 2 theta divided by 2. So this we can divide by the 2. This value can be divided by 2. So that what we got, 953.52 sin 628t. So these two are multiplied. So this is the instantaneous power. Now we'll go to the average power. Average power for the capacitive circuit is 0. Then RMS value. IRMS is Im by root 2, the general formula. So Im by root 2, that is 6.36 amperes. Similarly, maximum power PM, that is nothing but Vm Im divided by 2. We know the value of Vm and Im. So Vm Im divided by 2 will give the maximum power, that is 953.52 watts. Now we calculated all the parameters. Now we'll go to the second problem. A voltage of 100 voltage is applied to a capacitor of 12 microfarad. For 12 microfarad capacitor, the 100 voltage is connected across the 100 voltage supply. The current is 0.5 ampere. What must be the frequency of the supply? We need to find what is the frequency of the given supply. So the data, what are the data available? Vrms available, 100 voltage. Capacitor available, 12 microfarad, that is 12 into 10 to the power minus 6 farad. The current is 0.5 amperes. In order to find the frequency, first we will find Vm and Im, maximum value of Vm and Im. So Vrms equal to Vm by root 2, so that cross multiply this, so that Vm equal to root 2 Vrms. So root 2 into Vrms is given 100. So root 2 into 100, 141.42 voltage. Similarly, IRMS equal to Im by root 2, cross multiply this, so that Im equal to root 2 into IRMS. So root 2 into 0.5. The current value is given 0.5. So 0.707 amperes. So now we calculated Vm and Im, maximum value of current and voltage. By using that, we can find the frequency. So Im equal to omega c Vm is very similar to I equal to V by R, like that. So this is the capacitive reactance into voltage. So this omega is written as 2 pi Fc into Vm. What we need is only F. So bring other term in the denominator, so that Im divided by 2 pi C into Vm. Right? Only F is retained here. Other terms are brought into denominator, so that F equal to Im divided by 2 pi C into Vm. So this Vm and Im we already calculated. Now we can substitute all the values. So Im is what we calculated, 0.707 divided by 2 into pi into the C value is 12 into 10 to the power minus 6. The Vm we calculated as 141.42. So by simplifying this, what we got, 66.3 Hertz. So we calculated frequency also. So in this video we discuss about the solved problem based on the circuit containing the capacitor. 2 problems we solved. Thank you.